Earlier in the countdown, teams were able to troubleshoot an issue related to a hydrogen spike while filling the core stage tanks, and the rocket remains in a safe configuration as teams assess next steps. Here to talk with us today about today's operations and the path forward are NASA Administrator Bill Nelson, Artemis Mission Manager Mike Sarafin, and Associate Administrator for the Exploration Systems Development Mission Directorate, Jim Free. After the mission management team meets tomorrow to review data and discuss a path forward, we'll also hold a teleconference to keep you updated. We'll take questions from those of you in the room and over the phone. And if you're joining us on the phone, please press *1 to enter the queue. First, I'll hand it over to Administrator Nelson.
I am very proud of this launch team. They have solved several problems along the way, and they got to one that needed time to be solved. I am very grateful to you all for your patience. This is a brand new rocket. It's not going to fly until it's ready. There are millions of components of this rocket and its systems, and needless to say, the complexity is daunting when you bring it all into the focus of a countdown. You all, no doubt, have been up for some period of time. Our remarks are going to be short, and we will open it up for your questions. I want to say that the Vice President was here. She was pumped the entire time. She is very bullish on our space program and on this particular program of going back to the moon and going to Mars. We had her meet with assembled guests. We had her meet with members of Congress that were here. She toured the O&C building and saw the Artemis hardware there for the future. And overall, she had a very productive visit. And I would expect that you will see her at a future launch. I want to say that understand that scrubs are just a part of this program. On the space flight that I participated in, Hoot Gibson, the commander, 36 and a half years ago, we scrubbed 4 times on the pad. It was the better part of a month. And looking back, had we, after the 5th try, got off to a perfect mission, it would have not been a good day had we launched on any one of those 4 scrubs. So when you're dealing in a high-risk business and space flight is risky, that's what you do. You buy down that risk, you make it as safe as possible, and of course, that is the whole reason for this test flight, to stress it and to test it to make sure it's as safe as possible when Artemis II, when we put humans in the spacecraft. So for the details, let me turn it over to Mike Sarafin.
Well, good afternoon. It's been a very dynamic 48 hours since I was last here to talk to you. The technical issues that the team has worked through, they've overcome a number of them, but we ran into one that we need a little more time to look at. But the spaceport, America's spaceport, has been very dynamic. We watched a launch control center, a new spacecraft, and a new rocket come to life. And we watched the media show up. We watched thousands of visitors show up and America watch this new activity. So it's been a very dynamic 48 hours. Since we had our launch minus 2-day mission management team meeting, the operations team out of the Launch Control Center entered their launch countdown Saturday morning. And then Saturday afternoon, we had a couple of lightning strikes out at the pad. We have a 32-story tall rocket out there, and there were lightning strikes on towers 1 and 2, and our technical teams very quickly resolved that there were no issues with the vehicle through timely analysis and timely data assessment. Saturday afternoon, we also closed out an action from the Launch Minus 2-day mission management team, which was to re-verify our communications coverage associated with some late changes that we had with the rocket and the spacecraft, and the team got comfortable with the communications coverage plan. And then Sunday was largely a day of rest and a day of preparation for the team. And late Sunday evening, a subset of the team came in for the tanking meeting. Myself and our launch director, Charlie Blackwell-Thompson, and our propulsive elements came in at 10:50 this evening, or the prior evening, and we reassessed the readiness to load the vehicle with cryogenic oxygen, cryogenic fuel, and we were go for that. We had a go weather forecast, which was 20% chance of lightning, 40% chance of precipitation throughout the cryo loading period. And right around that same time frame, the team encountered an issue with the verification of the Orion flight software. It took about 11 minutes to have a command acknowledged to help verify the flight software, and it was a simple misconfiguration. One of the command and control modules was not activated, and the team quickly resolved that. And then once they configured it, they quickly worked through the software verification, and there were no concerns at that point with the Orion software verification. The tanking meeting itself was very clean. We were done in 30 minutes, and we gave the go for tanking. Shortly thereafter, the Kennedy Space Center went into a lightning alert, and the tanking was delayed for about an hour. And then once the cryo loading started, we started the loading of the hydrogen. The team quickly encountered a hydrogen leak at the 8-inch quick disconnect, which is our fill and drain, and that happened when they went into the fast fill phase. So they had to slow down the loading operation. They chilled down that interface, and they managed to work their way through the full cryo loading operation of both the core stage as well as the upper stage successfully. Once we got through the propellant loading on the rocket, both the core stage and the upper stage, they started the engine bleed. We talked at our flight readiness review about the engine bleed. We knew that that was a risk headed into this launch campaign, and it would be the first time demonstrating that successfully. We did encounter an issue chilling down engine number 3. We need the engine to be at the cryogenically cool temperature such that when it starts, it's not shocked with all the cold fuel that flows through it. So we needed a little extra time to assess that. When the team started working through that, they also saw an issue with a vent valve at the inner tank. So the combination of not being able to get the engine 3 chilled down, and then the vent valve issue that they saw at the inner tank really caused us to pause today, and we felt like we needed a little more time. There was also a series of weather issues throughout the window. We would have been no-go for weather at the beginning of the window due to precipitation, and later on in the window we would have been no-go for lightning within the launch pad area. So the team worked through a number of issues today. The team was tired at the end of the day, and we just decided that it was the best to knock it off and to reconvene tomorrow. So we've got a mission management team meeting at 3 p.m. Eastern. We're going to give the team time to rest, first of all, and then come back fresh tomorrow and reassess what we learned today, and then develop a series of options. It's too early to say what the options are. And then, as Jackie said earlier, we will come back and talk about where we stand tomorrow evening with all of you. Again, it's an incredibly hard business that we have. In spite of the challenges that we had, as well as some other constraints that the team had to work through and set up for. For example, we had 42 collision avoidance cutouts that we had to manage over the course of the 2-hour window. Most of those were only a couple of seconds long, but there were a few that were about a minute long. When you start thinking about the type of mission that we're flying, it really helps you understand just how unique and how complex the Space Launch System is and the Orion and the Artemis program is, we have this upper stage, the interim cryo propulsion stage, that lofts the spacecraft to a 975 nautical mile insertion orbit along with the SLS core stage. And with that, we need the performance from it, but we fly through part of the orbital debris field, the micrometeorite and orbital debris field. And then one orbit later, we commit to the point of translunar injection. So as we fly up through this orbital debris and then back down to low Earth orbit and then out through the point of translunar injection, we have to know where all these objects are, and that explains those 42 cutouts. And that is something that our operations teams were prepared to do today. We just didn't get to the launch window. So a number of challenges. We were ready for some of them, and the technical challenges we encountered on the engine bleed and the vent valve are just some things we're going to have to go look at today, look at tomorrow after we get a little smarter and get rested. So with that, I'll pass it to Jim.
Yeah, so good afternoon. So the administrator and Mike covered a great deal of things. I'll just highlight a few things for me. You know, I sit in a different vantage point than Mike does. His is a lot more fun, by the way. But we, you know, we're in the LCC, and I found some things in the team today. This was a really important attempt for us. We talked about that after Wet Dress 4. There were a lot of questions of, you know, should we have rolled back, tried to do another test? We felt and still feel like going for today was the right thing to do. And that comes in a few ways. Our launch team was really, I'll say, pushed today. They were working a lot of issues. They were looking at the compressed timeline with that hold at the beginning, and we were filling all 4 tanks at the same time at one point, really pushing our team through a timeline. Weather, you know, Mike talked about some of the weather. We talked about lightning. Weather was coming in and out. We were actually not able to go at the beginning of the window like we thought. There was a lot of comms from the launch weather officer. The hydrogen out of spec that Mike talked about when we went to manual control, that's something we did on the locks when we had some issues loading locks the first time. Going to that manual control to me is learning. And getting through the first hydrogen leak that we had, that was the same leak we had on the same line to the same level. And when we started to do the manual fast fill, honestly, it kept climbing, and I thought there's no way we're going to get out of this, and that got us out of it. So to me, what we pushed the team through, and I know we always get a lot of talking about the team too much, but we continue to learn. That's what we're doing. We're testing, I think Bob Cabana said it, we're testing the people and the processes. So we've put ourselves through a compressed timeline. We're going to get some shorter launch windows we'll have to deal with, where these skills will help us. I know you've heard from Charlie about extending our timeline about an hour earlier to give us time to work things. I think that helped us today to work things. And frankly, engine 3 that Mike talked about, we definitely didn't get down to the temperature we wanted, but the other 4 weren't as low as we would like to. So there's some things going on that the team needs to go off and look at the data and understand how this is different from what we did during the green run at Stennis, and then figure out a path forward, which is ultimately where we want to go. We're not going to have all the data and the implications today. I'll reiterate that, what Mike said, but we felt we owed it to you to share everything that we know. So, and I can assure you there was no other group of folks, not just the folks that worked last night, but the folks that started this countdown. There's no other group that wanted to get through this successfully than those people. So with that, I'll turn it back to Jackie.
Thanks, Jim. Just a reminder for folks joining us on the phone, you can press *1 to get into the queue. But first, we'll take some questions from the room. Marcia Dunn, AP.
Marcia Dunn, Associated Press, probably for you, Mike, or Jim. Is Friday or Monday even feasible since you're dealing with an engine? And might you need to replace this engine? this be a problem unique to this, but I guess not, since you said that you didn't get the temperatures on any of them that you were looking for. I'm just wondering what could be the worst case here.
Yeah, Mike, go ahead.
Okay.
I'll add on.
Yeah, Friday is definitely in play. We just need a little bit of time to look at the data, but the team is setting up for a 96-hour recycle. So they're still holding in the launch countdown configuration, and we're preserving the option for Friday. They're replenishing the commodities out at Launch Complex 39B. You'll see some of those activities tomorrow. And right now, the indications don't point to an engine problem. It's in the bleed system, the thermally conditions the engines. We did change the diameter of that from Stennis, where we did the green run testing, to here, and we never fully got into the engine bleed configuration through the prior wet dress attempts. And again, that was something that we talked about at the agency flight readiness review as a known risk to our launch campaign. And at that time, we said we would not launch unless we got through the demonstration of our ability to thermally condition the engines. We need that in order to start the engines and run them successfully. So we just didn't get there today. And again, this really points towards an engine bleed issue on the core stage side, not on the engine interface side. So I don't know, Jim, if you have anything to add to that.
Yeah, I just add, we actually stayed loaded longer to try and figure it out, so that we were trying to save as many cycles on the tank as we could. So I think we tried to, I'll say, run it to ground as fast as we could, and then once we were outside, seeing we could launch and the way the pressure in the tank was going, it's like, hey, it's better just to stop and regroup and stay in the 96-hour that Mike talked about and figure it out.
Did you make the diameter bigger or smaller when you made the change?
Larger.
So you did make it bigger?
Yes.
And we also did it, and you'll hear more from John Honeycutt on this probably tomorrow, is we also, where we did the test in the flow is a little bit different than we did at Stennis. All of those decisions were made hoping for the benefit of physics that went with all that from the expert's opinion. So that's what we have to figure out.
Joey Roulette with Reuters.
Thanks. A question for Mike or Jim. I know you said Friday is in play, but given the magnitude of the issues and the combo of things that you guys have to look at, is it likely you guys launch on Friday, or is it unlikely? Could you kind of assess that? And can you give some clarification on whether you think this is related to the quick disconnect issue you guys found in the wet dress rehearsals? Thanks.
So you're asking about the likelihood of Friday?
Do you think it's maybe likely that we go on Friday, or
There's a non-zero chance we'll have a launch opportunity on Friday. Yeah. But we need time. We really need time to look at all the information, all the data, and we're gonna play all 9 innings here, and we're not ready to give up yet.
And if you could kind of clarify a little bit whether this is related to what you guys were looking at in the wet dress rehearsals with the quick disconnect leak issue. How related might it be, or if it's independent, maybe, I don't know.
I would say, and again, this is probably a question that's better answered by John Honeycutt, but during the wet dress rehearsal, we saw issues at both the 4-inch and the 8-inch QD in terms of our ability to retain enough pressure to properly seal those, such that we didn't have a hydrogen leak. And we never got to the engine bleed itself during the wet dress. We knew that. So the QD problems that we saw during wet dress have largely been mitigated. And in fact, the 8-inch today was the issue that we had a little bit of leakage on that they managed to work their way through by slowing the fill and chilling it down, and then that properly sealed it, and we got a full load. We weren't able to get a full load in our first 3 wet dress attempts. The 4-inch QD that we previously had problems with on, I think it was wet dress 4, worked just fine today. So I would say that the QDs really had no material impact on the on this hydrogen bleed setup. And I don't know, Jim, if you have anything to add
No,
on
I
that
think
one.
you're exactly right. Yeah, that's what I was trying to say earlier. We worked the 8-inch problem the first time, rolled back, figured that out. 4-inch, we couldn't pressurize because that was leaking. Today we did that, so yeah, I think we're in good shape.
Michael Sheets with CNBC.
Michael Sheets of CNBC. My question is for Mike. I'm curious to get a little more learnings on the other side of things, which is the possibility of a rollback. Given the data that you've seen so far, how likely does that seem? And if you were to roll it back to the pad, where does that reset the timeline in terms of your guys' next launch opportunity?
I'd say that's getting ahead of our data reviews, and we need the team to get rested and come back tomorrow, and we'll see what the data tells us. I'll recycle a line from earlier. There's a non-zero chance, but we're going to do our best to see where the data leads us, and if we can resolve this operationally out at the pad, there won't be any need for that. And if we can resolve this operationally out at the pad in the next 48 hours, 72 hours, Friday is definitely in play. So we just need to see. We need to see what the art of the possible is. We need the team to digest what we've learned, and we'll take it from there.
Thanks, Mike. Ken Chang with the New York Times.
Yeah, hi. This is for Mr. Sarafin. I was wondering if you could give us a quick primer about how the hydrogen bleed system works. Sounds like it's the plumbing from the hydrogen tank to the engines. What was changed and why? And did anything like this occur during Green Run at Stennis?
Yeah, I will defer that one to John Honeycutt tomorrow. I know we increased the diameter of the bleed that is used to increase the flow to the engines, but beyond that, it would be kind of getting out of my experience base to talk about what other changes there were. So if you could ask that to John tomorrow.
Jeff Faust with Space News.
Jeff Faust of Space News. For Mike Sarafin, you also mentioned an intertank vent valve issue. I wonder if you could provide some more details about exactly what that issue is, and if you hadn't had the problem with the engine bleed on engine 3, would that have been a constraint to launch alone?
Yeah, we're still trying to understand what happened with the intertank vent, but it was clear that there was a leak at that vent valve, and the challenge that created was we want to increase the pressure in the tank in order to establish the hydrogen bleed, and the vent valve wasn't cooperating with us. So it was this delicate balance of maintaining the pressure to establish the bleed on all 4 engines, and engine 3 was not seeing the temperatures that it needed, and the vent valve complicated that, and that's at the point where the team decided that it was appropriate to declare the scrub. Because we just weren't going to make the 2-hour window, and then it just was one of those situations where we just knew that we needed more time.
Thanks, Mike. They're keeping you busy. Kristen Fisher with CNN.
It's actually Rachel.
Oh, I'm so sorry.
We look a lot.
I'm so sorry.
Rachel Crane with CNN. Mike, you mentioned earlier that you didn't see temperatures for all 4 engines that you were anticipating. We just heard a lot about engine 3. Can you tell us a little bit about the temperatures you were seeing with the other engines and what the issue was?
The other 3 engines were meeting the temperature range, or were on trend to achieve what we would need to have a proper start. It was just engine 3 that was just for some reason not getting to the proper temperature range.
On the phone, we have Chris Davenport with Washington Post.
Hi, thanks so much, I guess, for Mike. What is the temperature that you need the RS-25 to be at in order to launch? Just wondering what the criteria is for that and how far away you were on that third engine. I'm also wondering how you ended up being able to fix that hydrogen leak. It just sort of seemed to go away during tanking. Thanks.
Okay, so as I recall, and again, it would be a good question for John Honeycutt tomorrow. The temperatures on the engines, it's about 500 Rankine that we're looking for on the engines before they're thermally conditioned. I don't recall exactly where the engines were, but engines 1, 2, and 4 were pretty close to that, and then 3 was just not getting there. And then the hydrogen leak, in terms of resolving that, hydrogen is an incredibly small molecule. It's the smallest on the atomic chart, and it doesn't take much of a gap in order to have a leak in a quick disconnect. And there are soft goods in there between the mechanical plates, and sometimes it just takes a little bit of a cold soak on both sides of that interface, or if there's a little bit of differential heating on either side of that, it can actually cause a little bit of a gap. So the team has experience with this. Our cryo team is very good at understanding the thermodynamics going on, as well as the timing of it relative to how long there's been fluid flow, and they basically recommended when we initially saw the leak on the 8-inch QD to stop flow, because when you have hydrogen leaking, it creates a flammability hazard. So they stopped flow, and then they slowly increased it, as Jim described, through some manual flow procedures, and they just kind of slowly let the fluid through, slowly let it through to chill both sides of that interface. And in some cases, you can actually thermally condition both sides of that, such that they'll seal up and seat properly, and that's what the team did today. And it's kind of a delicate balance. You want to fill this thing as fast as you can to achieve your launch window, but when you run into a problem like that, you need to slow it down. And when you slow it down, you can achieve the proper sealing and proper seating. So it was again a little bit of science and a little bit of art that our team worked through today by healing that hydrogen leak.
Lauren Grush with Bloomberg.
Hi, this question's for Jim. Earlier you said you were confident about the decision to go for a full countdown today instead of another wet dress rehearsal. I'm wondering if there are any risks, extra risks involved with going for a full countdown, apart from the launch itself, rather than doing a wet dress rehearsal.
I think we just rolling out for another wet dress has some cycles on how many times we roll out, so you introduce risk that way. We felt like we understood that 4-inch leak that we had during wet dress 4, which today we proved that we understood it. We understood how to operate with the leak on the 8-inch line. So from my perspective, that's where I'm kind of basing our fact to make a run for launch in this launch period is still the right decision.
We have another question on the phone from Eric Berger with Ars Technica.
Yeah, hi. Just to follow up with Lauren's question there, Jim. You have done effectively 5 wet dress tests now at Kennedy, and you haven't gone all the way through on any of them. Can you just talk maybe a little bit more about why you don't think it's prudent to complete a wet dress test, which would have identified, I think, this RS-25 chilling issue today if you had gone through the wet dress? Thanks.
Yeah, so I guess 2 things, Eric. I'd answer it the same way, because we still would have taken another cycle of rolling out and back, and we're going to learn every time we come out here. If you go back in history at how many times the different Apollo vehicles came out and tested prior to launch, how many times they scrubbed. The administrator talked about how many times he scrubbed on a vehicle that had flown multiple times. So we're going to run into these issues, and we'll figure them out as we go. But until we put the whole vehicle together, had we come out for another wet dress, the vehicle would not have been the complete that's ready to go out there today with all the closeouts, FTS installed, everything we learned about the flow, everything we learned about FTS, working with the range to get a 25-day time period before we have to retest. So yeah, I agree. We won't know until we know, but we also won't know until we try. And we felt like we were in the best position to try.
Marina Corrin with The Atlantic.
Hi, Marina Corrin with The Atlantic. This is for Mike and Jim. After the scrub, Stan Love came to the press site to talk to the reporters, and they asked him how he felt. He said that he was a little disappointed, but he was not at all surprised. It really sounded like he didn't expect SLS to get off the ground today. I'm wondering if you were surprised or unsurprised with the way things unfolded today.
Yeah, I mean, I'll start. I'll say what our deputy administrator told her family when they were coming for her launch. Plan a week trip to Florida for a vacation, and you might see a launch, which is exactly what I told my family. We're gonna, and the administrator said it, we're gonna launch when we're ready, and that's our approach. I said there's nobody that came wanting more for that vehicle to launch than our team that has worked on this. Not just our team, the launch team. There were a lot of folks that have put their careers into this, but everybody wants it to be successful. And ultimately, our job is to make it as successful as we can. And we might get to another one where there's another issue and we decide not to fly. That's the most important decision we can make, because we are building. Kathy Leaders gave a great speech at an awards event the other night, and I was talking about Artemis I, and then she got up behind me and said, "This is just the beginning." So we need to make sure we do this right and prudently.
Yeah, I think we all want to see that next milestone, that next step, and seeing smoke and fire is something that everybody enjoys. But we're not going to let another hurdle deter us from trying to achieve that next step. And yeah, this is an incredibly hard business. We're trying to do something that hasn't been done in over 50 years. And we're doing it with new technology. We're doing it with new operators and new teams and new command and control and new software. And as Jim said, we're learning all along the way. This is one of the things that we love about the agency is it's a learning organization, and we take pride in lessons learned and applying them. And I think the fact that we went from having issues just loading the core stage to getting all the way through cryo loading and having a fully configured vehicle and just not quite getting to this engine bleed is a sign that we've applied a lot of lessons learned, and we are trying to get to that next step, and that again is not going to deter us from trying to achieve it.
Here in the third row.
Hi there, Tim Fernholz from Quartz. I was curious, we heard on the commentary that the flight controllers came up with a couple plans to try and fix the engine issue during that hold. Can you tell us what was tried and maybe give us some insight into the scene in the control room when those decisions were being made?
Yeah, I'll take a crack at that. There are what we call pre-planned procedures that the team has, and the team worked through those, like doing when we had the initial hydrogen leak on the 8-inch QD. You do what they call a stop, flow, and revert, and then you try again. And those things the team worked through very efficiently, and it was very methodical, and they had, again, to kind of have this delicate balance of wanting to increase the flow rate as quickly as we could to get that tank full so we could meet our launch window, but do it at a slow enough pace that that we didn't spring another leak, and that the interface could get thermally conditioned and seal up. And they worked through it very methodically. And when we ran into the engine bleed condition. You know, they noted it. They worked through the fact that 3 of the 4 engines looked pretty good in terms of the thermal conditioning, and this engine 3 was the outlier. They tried a couple of steps. They consulted with the engineering teams that provide technical support from the design center. In this case, it's Boeing and Aerojet Rocketdyne are the technical experts, whether it's on the core stage or the liquid engine side, and they worked together very efficiently as a team. There was quite a bit of chatter when we got outside of the pre-planned contingency, and then they brought back a strategy on how to reestablish the engine bleed, and we just weren't successful when we ran into this intertank vent valve issue that complicated our ability to maintain pressure there. And it was at that point that the team just focused solely on managing the pressure of the tank, because you're preserving the flight hardware within its design limits. And then once they did that, we decided that it was time to knock it off.
There's also a process. I mean, the team goes over to an anomaly loop where they're working things at that particular non-conformance or issue, and they come back and say, here's our plan. Can you give us some time to work it? And they'll sometimes talk about a time and go off and play it against a software model in another firing room or back in the design center in Huntsville or out at Aerojet Rocketdyne, and then come back with that data. And the NASA test director and the launch director are encouraging them to, hey, we haven't heard from you in the time frame, right? Because they're trying to get all the data, but those two are trying to manage the flow and what we have left in the launch window. So that's kind of the process that's always going on across all anomalies, not just that one.
Tom Costello with NBC.
Hi, good afternoon. You all are probably exhausted, so thank you for taking time to talk to us and talk through all of this. I'm wondering, as you do talk through all of these steps, and you all have mentioned various experiences that the Apollo crews and the Apollo mission control also dealt with, does it give you a new appreciation for, or as you look at all of this, do you hearken back to what your predecessors were doing 50-plus years ago? I'm just wondering how you think about where you are today, and you juxtapose that against what the Apollo folks went through 50-plus years ago.
Randy Bresnik said it best the other day, right? They didn't know it could be done, which is even more impressive, right? We've seen it done. We're trying this with a new vehicle, so it's really impressive to me to think they didn't even know that it could be done. It's kind of, you don't know how hard it is because of what's laid out in front of you. So I think for that, the shuttle program, the ISS program, those are all programs we learn from and have an appreciation for the challenges that go with it. But my faith in this team is ongoing. So I know we'll get through it because they've seen it done before and they understand this vehicle.
Tom, one thing that will show you the difference between Apollo and Artemis. They went step by step. There was Apollo 7, then 8 around the moon, then 9 where back in low Earth orbit, where they separated the lunar lander and prepared that docking again. You think about that, 7, 8, and 9. That's all wrapped up in this Artemis I. And then they went on to Apollo 10. Tom Stafford, who, by the way, was with us today and got a standing ovation from our guest. And then 11, and that was the part of what is going to be Artemis II, and then Artemis III. So it's really a compression of a lot of the things, and we're standing on the shoulders of those who had been there before, but with a completely different vehicle.
So we're running up on the end of our time. I think we have time for 2 more. Micah Maidenberg with Wall Street Journal.
Thank you. Mike Amator, Wall Street Journal. Hey, Mike, you talked about the issue being on the core side and not on the engine interface side. Could you kind of elaborate on that? And have you had any conversations, or anybody on your team had any conversations initially with the folks at Boeing, just given their role on the core side?
Well, we certainly did discuss whether or not there was an engine problem. And Marcia's question earlier was kind of alluding to, do we need to remove and replace an engine? And there's no indication that we're in that type of scenario at this point. Boeing is a part of our engineering team that is in the Launch Control Center. Boeing is on the mission management team, and they're integral to the overall operation. And we did tap their expertise, and we have a whole host of technical experts aside from Boeing. Our NASA Engineering and Safety Center, some of the tech fellows are involved from that organization, as well as our NASA chief engineers from the Marshall Space Flight Center, folks like Dr. John Blevins and a number of other folks, all weighed in and helped troubleshoot the issue today alongside our Boeing and Aerojet Rocketdyne partners. And that's kind of where we got to today. Was at the end of a long day, we ran into not one issue, but kind of a compounding issue between the bleed and the vent valve that we just again decided that it was appropriate to knock it off given the configuration that we're in. So yeah, that's kind of where we got to.
One last question. Irene Klotz with Aviation Week.
Thanks. This is kind of a physics question. Is there something about the position of the main engine 3 that is makes it susceptible to this kind of situation, or could this have randomly occurred at one of the other engine positions?
Only because I talked with Honeycutt, he brought this up. He asked his team to go off and look at that. And I think he'll probably bring that answer back to you tomorrow. He didn't anticipate there was, but they're not leaving anything off the table. So.
Thanks. That's all we have time for today. As I mentioned, after the mission management team meets tomorrow to review the data and steps forward, we'll hold a teleconference in the evening. So thank you for joining us, and tune into NASA TV for continuing coverage of NASA's Artemis I mission.